Yes, hello and thank you, Scott. Hello everybody once more from my side. I'm glad you were interested in learning about our industry solution for heritage, PointSense Heritage. My name is Jana Siebenroth. I'm the product manager for this software, and I will guide you through the next about 60 minutes on that software package. First of all, to give you an idea where in the laser scanning process PointSense Heritage is placed. First of all, you capture your scans on site to scan your object from different positions. And then in the office, you will go on and register the individual scan positions into one common reference system. And you will also pre-process your scan data by cleaning and filtering it. And all this is done in some pre-processing tool like Scene or CloudWorks or Trimble RealWorks, etc. And then later on you will go on and post-process the scan data, and you start interpreting and modeling the scans in your design tool. And today we're talking about AutoCAD, and our PointSense Heritage is a plugin inside AutoCAD. And of course, you can get your scan data from your pre-processing tool. If you have seen, you can directly export RCP or RCS files, which is the Autodesk Point Cloud format that can be attached to AutoCAD drawings, or you can use Autodesk Recap in order to create RCP RCS files from your scan formats if you have like a scanner using CloudWorks. With PointSense Heritage, you can not only use scans but also photographs, but I will come to that in a few minutes. First of all, to give you an idea what PointSense Heritage is or what it's meant for, it provides tools for users in the field of archaeology and historic preservation, which help you to create your typical deliverables like image plans, layout plans, elevations, sections, and even 3D models for the documentation of either historical buildings or archaeological excavations. And all this is done inside your familiar AutoCAD environment, if AutoCAD is familiar to you. Native AutoCAD does already provide some point cloud tools for displaying the point cloud in different color options. It provides tools for cropping and sectioning and also for snapping to the point cloud. But with our PointSense products, there are multiple features added, like in the PointSense Heritage package comprises the features of PointSense Basic and PointSense Pro, so it also contains ortho image functionality or the scan navigation tool, as well as the scan manager, and also some more pattern recognition tools from the PointSense Pro product. And it adds to those PointSense Basic, PointSense Pro features, it also adds tools to evaluate point clouds together with photos in order to unwrap photographs and point clouds to the plane to get nice true-to-scale image plans. All right, and your benefits from using PointSense Heritage are you get a richer detail by combining laser scans and photographs, and you can concentrate on the essential by clipping and coloring the point clouds. As I already mentioned, it adds numerous tools for modeling and analyzing inside your familiar CAD, and of course you can create true-to-scale image plans by unwinding an auto projection of point clouds and photographs. It also has some intuitive navigation tools for navigating your scan data while processing it. So let's come to the functionality in more detail. You can of course clip your point clouds in order to remove obstacles or to crop to your areas of interest. And you can define slices, thin sections, in order to digitize profiles or layout plans, as well as elevations. This is symbolized here on the left-hand side. A new tool in version 16.5 is the possibility to define a horizontal slice at a defined elevation. This is useful for architects. Sometimes they have the restriction to create a floor plan for the building cut at a certain elevation, for instance at 1 meter level. Then, as already mentioned, you can colorize your point clouds in order to create colorful elevation maps or to visualize areas of your point cloud thematically. For instance, if you want to color by age or by certain materials. Then we have plenty tools for modeling and analyzing surfaces. So we have pattern recognition of polygons and lines, which you can then use for a combination with native AutoCAD tools for 3D modeling. We also have pattern recognition for cylinders. You can fit a cylinder by only 2 clicks. And we have pattern recognition for planar faces in point clouds, where you can fit a plane by just 1 click in the point cloud. A new feature in version 16.5 is the feature for simultaneously fitting multiple polygons. That makes processing of the point cloud even more efficient. It speeds up the creation of cross-sections, e.g. for instance for catacombs, or the generation of contour lines. You also have the option to automatically create solids with this tool, and here's how it works. You first use the multi-slice command to create the profiles of the point cloud, and then the algorithm fits polygons to those slices. And if you have enabled the option for creating a solid, you will get a solid as well. Let me just demonstrate so you get a better impression on the workflow. So in this example, I have already created the slices by running the define multiple slices command. You can see those slice sections in the section manager already. I will just turn off the all points section, and if I zoom in here a little bit further, you can see that the multiple slice command has defined slices at defined distance and defined slice thickness. And I can now use those slices to run the multiple profile command, multiple polyline command. I can select one slice here and I can isolate it. And if I now create a polygon first, I can fit a polygon with variable number of vertices. Need to switch to the top view first. And this command allows me to roughly click an approximate polygon, like I'm doing right now. See very quickly, then I'll just close it, hit a button, and the algorithm will fit this approximation to my point cloud slice, which and this polygon I can then use as starting point for fitting the polygon in more point cloud slices. I will won't select all 50 of them. I will just, for you to show how it's working, I will enable just 5 slices. So the following command is the fit polygons in multiple slices command. It will fit polygons to all those slice sections which I've switched visible in the in the section manager. So I run the command, and I'll have to select approximate an approximate polygon, a starting point. I'll go to select objects and select what I've just created. And then I could check the option to add more points to the polyline I've just selected with some more detailing, and I could also check the option to create the solid surface. But for us not having to wait too long, I would just hit OK right now, and you can see what happens. You can see that the polygon fitting is going on, and the algorithm automatically switches through those sections I have selected and fits the polygons to the outline of the point cloud there. Last slice, I think. Okay, and you can imagine that this way you can either create cross-section profiles or contour lines very quickly, just to give you an impression how the result might look like if I have selected all the point cloud slices. So here are the cross-section profiles for the complete tower top. And if I check the option to create a solid, you will even get, well, let me switch off the point cloud here. You can see that a solid has been created automatically as well. All right, I think it gives you an idea how this new tool in version 16.5 is working. We have more tools for modeling surfaces and also for analyzing surfaces. Next tool is a tool for flatness analysis or plane analysis. This is a very powerful tool not only for solid modeling but for in the field of heritage and archaeology. Solid modeling option will be of most interest for you, I guess. But you can also use it for volumetric calculation and also for analysis of deformations of planar objects, and it's also suitable for terrain modeling. So this tool is not only included in our PointSense Heritage solution, but also in PointSense Pro, and there was also in the industry solutions like PointSense Plant and PointSense Building. Here's an example how a terrain model has been created using this tool. You can control the accuracy of the results by setting the parameters in the parameters dialog, and you can have options to create to display the deviations from the reference plane in an exaggerated scale. You can flexibly choose the reference plane and the grid alignment, and it's you who defines which results you want to produce using the flatness analysis tool. Let me give you an idea, a rough idea about the workflow. I have a brick wall here. It has only been scanned from one side. I've already used the plane fitting tools in order to fit the plane to a reference plane to the wall, and I have already moved it a little bit further from the surface because I want to model the wall in 3D. And I can now run the plane analysis tool. I have to select a plane as reference surface. All right. And then there are parameters that I can set, so I can tell the software how far from the reference plane I want to take the points of the point cloud into account. Here's the option for a saturated scale. If I'm interested in the deviations, it makes sense. If I'm interested in in a solid close to the real world, then I would have to leave it to 1, which I will do. And then there is the grid size. With defining the grid size, you define the resolution of your model as well as the resolution of your deformation analysis. And you will can always check how many cells will be calculated for deformation analysis. If I say OK, I will get a warning because quite huge number of cells. I say OK anyway. And on the right hand side, you can check whether you want to create a solid model or whether you just want to create a polyline grid with the deviations, or a grid of points where you then can, which you then also can use in Civil 3D. Or if you want to create a point cloud creation is meant that the deviation values, deviation from the reference plane, are written into the intensity column of your new point cloud, and this way you can colorize by intensity, but it's not the intensity but the deviation that's displayed in colors. Let me show you the results here. I have prepared those for you, and if I turn off the point cloud for once in the plane as well. Here's how the solid that's been created will look like. I think this has been created with 5 centimeters cell grid, so it's not very detailed, but good enough to recognize it as a brick wall. Another result you can create with this tool is you can create this deviation grid, which I've mentioned, and it's consisting of 3D polylines as a grid, and at the nodes of the grid we have a text that tells us the deviation from the reference plane. And if I turn on the point cloud once more, I can select the point cloud, and as our algorithm has written the deviation values to the intensity column of the point cloud, I can colorize by deviation, and I've also already prepared a legend. You can create a legend with using this legend tool in the section manager. If I zoom out, you have a nice deviation map with a legend added to it. I think that gives you an idea how you can use the plane analysis tool not only for creating terrain models but also for creating models of other plane-like surfaces. Let me show you a few more tools of PointSense Heritage. There are tools for analyzing cylinder-shaped and conical-shaped objects, like this tower over here on the left-hand side. With this tool, you can unwind the point cloud for easier analysis, and you can also get a color-coded unwrapped point cloud, color-coded by deviation. And as mentioned already in the PointSense plant section, you can create reports and export the data to Excel and ASCII formats. I think this option is more of interest for tank analysis. I think in the field of heritage and archaeology, really the modeling option, the option to create solids is of more interest with this tool here. To give you a rough idea how this tool can be used with a conical shaped object like at this tower, you can fit frustum conical here to the point cloud by snapping a few points, and then the algorithm uses the ideal cone in order to calculate the deviations and to model the deviation from this ideal cone. Here, let me switch now the command has been started, and it's working very similar to what I've shown you with a planar surface. So let me jump a little bit further. You again have lots of parameters to be set, and the choice of the results you want to create. And yeah, let me switch further forward. In the end, you will get a solid, or if you've checked, you can get a deviation grid and the colored point cloud in the end. So that's what you can do with this cylinder or conical analysis tools. Of course, you can also calculate volumes at different intervals. Then, as mentioned, PointSense Heritage does not only use the point clouds, but also photographs for creating 3D models or image plans. In PointSense Heritage, we do have tools for manually orientate photographs. That means calculate the position of the camera during the shot, and not only the position but also the direction and the focal length. So we have manual tools to do that using control points, but we also have options to import photo projects from Argisoft Photoscan as well as Autodesk Recap Photo. And we have those imports to give you a way for fast automatic image orientation rather than going the manual way. And those oriented images, they are used for multiple image processing for photogrammetry, but also for so-called monoplotting, where you click on the photograph and get a 3D coordinate on top of the point cloud. And we can use those oriented images for creating true-to-scale image plans and orthophotos. So let me in version 16.5, the Argisoft Photoscan project import is new, and like I said, we can use multiple image photogrammetry. If we don't want to scan the object or don't have the option to scan the object, we can take photographs around the object to create a point cloud and also to model directly from the photographs in 3D. So we can drive highly structured facade plans of highly structured facades, but we can also model 3D, like you can see on the lower right here. We need at least 2 oriented images of an object which have enough overlap, so we can calculate 3D coordinate. A new tool in PointSense Heritage is the new image management that helps us to easily work with multiple oriented images. It simplifies the setting up of viewports for multiple image processing. Swapping the photos to be processed is now child's play with this new tool, and this tool is perfectly suited to process photos from large photo projects like from Argisoft Photoscan or from Recap Photo. And to give you an idea what I'm talking about, I will jump into AutoCAD and demonstrate how this photogrammetry tools are working. We have here not a laser scan, but a point cloud that has been created by Argisoft Photoscan using photographs only. And zooming in here, you can see that the edges of this window over here, they are quite fuzzy. That's due to the photo resolution. But what I can do now, I can just fit a plane here, a facade plane, to that point cloud to give me something to be able to draw on later. And if I hit OK, you can see the points I've collected, and you can see the mean and the maximum distance of those points from their average plane. If I hit OK, the plane is now created, and I will also switch the user coordinate system to that plane. Now still the point cloud is not very dense, so I will turn it off here, and I will just run the new image management command. Oh, by the way, I have already imported Agisoft Photoscan project, which I will now use with the image management tool. So I will start the image management here. And you see the list of images is still empty, but I will now select I will just select the folder where I have imported my Agisoft Photoscan project to. This is the folder, and if I switch back to the image list, I have now all the photographs that have been used to create the point cloud, which was visible before. And with the image management tool, I can now set up viewports very quickly, and I want to see my model on the right-hand side, so I don't want to hide the model behind any photographs. And I set the left viewport to camera navigation mode, and now I just need to select the photograph I want to draw on just by double-clicking in the image list, and you can see the geometry in the foreground and the photograph in the background. And you see with the photograph I have much sharper edges, which I can now digitize. Before I start digitizing, I would just turn off the Cubit plane layer and turn on my digitization layer, which is green and for you easier to recognize. And since I have created a plane already, I can directly use the AutoCAD commands, so I don't have to switch back and forth between different photographs right now. So I will just create an arc here and create an arc on the other side, and let me just draw a polyline to complement this here. And this way I could continue around the window and then start digitizing the rest of the facade to get a nice facade plan. But what I like to show you as well is how you can use these elements to extrude them. So I select them and run the extrude command. You see the object is now snapped to my mouse cursor. I will switch back to the camera navigation window, but I will select a different photograph to get a nicer, better view of the window, to see the depth of that frame over here, and to fit my 3D model exactly to the depth of this part. And I have it here. I have it now in here in 3D, and if I turn off the image manager and switch on the point cloud once more, I have to switch back here to 3D visualization style to see the point cloud. And let me go back in here to turn off, to unload the image. So I right click and I scale that image to a smaller visualization. So here we can see that the model I've created by using the photograph really fits into the point cloud that has been created with those photographs previously, but I get a much more exact shape than I would get when I model this point cloud. So here we see another example. There is no point cloud derived from those photographs. I just used those two photographs, switching back and forth between the two of them, and created first a 3D facade plan, and then I just need, if I really want the facade plan, I can run the flatten command and select the objects and flatten those objects to the facade, to the main facade plane. Here you can now see the result, and I could now use AutoCAD commands to annotate with distances and other annotations. Okay, let me go back into the presentation. The monoplotting tool of PointSense Heritage is meant for drawing on a high-resolution oriented photograph. That's useful if your scan is not as dense as a photograph can be. And the 3D geometry is directly generated on top of the point cloud. So it's very similar to what I have just presented to you, but rather than having to create a plane to draw on, I can just select the point cloud itself as a surface, and then the software calculates the intersection between the image array and the surface, and this way we are able to click in the image and draw directly on top of the point cloud. So this is just another approach, this monoplotting. Then we have tools to create orthophotos and true orthophotos inside PointSense Heritage. A true orthophoto can give you a much denser image information than the normal ortho image function will give you. And as ortho images as well as true orthophotos can be used as image plans, because everything that's parallel to the image plane is projected through to scale, but only those things which are parallel to the projection plane. So if you have facades with a lot of planar surfaces which are parallel to each other, you would fit a main plane and then everything and use this as image plane. If you have other facade shapes like you can see in the sketch down here, you would rather like to unwind the point cloud or photographs in order to get an image plan. So you can unwind point clouds as well as photos of towers, walls, facades, ceilings, frescoes, and more into the plane for digitizing and evaluating details on top of the resulting image, and to measure true length. Because if you would create an ortho image of those curved surfaces, for instance, you would never get true length on top of those curved surfaces. You will only get shorter length. So this tool is very useful for true to scale image plans of curved surfaces. Here's an example of a tower. Same tower, we used the cylinder analysis tool previously. You will have to fit a cylinder to the point cloud and use this cylinder to be unrolled into the plane. But since this is very abstract, I would like to demonstrate this tool for you live inside PointSense Heritage. Here we have a scan of a tower, and I use this fit cylinder tool to fit the ideal cylinder to that scan data. The scans have been taken without colors, but there have been photographs taken in addition to that scan. to that laser scan. And I will now use those photographs and the cylinder surface to unwrap an image plan, to create an unwrapped image plan. You can see that inside this oriented photograph, we have a lot of sky and also trees, so I would like to remove those parts of the image before I start the calculation. So I run the clipping command, select the photo, and I would click points to crop the image to the area of the fitted ideal cylinder. All right, and finally close that polygon, hit OK, and you can see the image has been cropped to that shape. Same has been already been done to the second image. So just for us to not to be confused by the point cloud, I will just go in here and use from the image computation toolbox, I will use the unwrap cylinder tool. You can see we have options to unwrap other surfaces as well. In the cylinder unwrap tool, I need to select the cylinder first, which is my projection surface. We have scanned the and photographed the cylinder from the outside, so this is okay. And I can now have to select a reference point to tell the software from which point I want to do the unwrap. Click in here. And since I did not take any photographs, not from all around the tower, but only from one side, I will just select the option relative to the reference point. So that's the reason why I needed to define the reference point. And let's unwrap 6 meters left and right of this reference point. Say OK, and now I just need to add the photographs to the algorithm. Select both of them. I check. One is here and the other one is there, and I have options to shift them in this list, and I have several overlapping options. And you can see we can also apply automatic brightness corrections if we want to. Last, at the end, I have to define a name and a format for my resulting image, and say save. I can also check the resolution here and correct it a little bit. I could also select a different background color if I want to, but I keep it as white for the resulting image, and then I just hit compute projection. Yes, I want to overwrite the existing image, and the algorithm does calculate the unwound raster image from just using the information of the photographs. This takes a few seconds. Depending on the machine power and on the number of photographs, this process may also take a little bit longer than in this example. The resulting image is will now be placed close to the cylinder, and as you will see, the software will ask me if I want to switch to the plan view. It also then sets the user coordinate system to the image, so I can directly use AutoCAD commands to annotate my image plan. I would just measure the window width in here for you, and put in another measure for the width of this smaller part here, and let me also annotate the height of window in here. What I like to show you is I have prepared from the same tower an example where we created an ortho image rather than a true ortho photo rather than an unwrapped image plan. And here you can see that in the ortho photo the width of the window is much shorter because it's not the true length, it's shortened because of the ortho projection, while when unwinding it, we have the true, we switch back, we have the true width of the window, which is much wider. All right. I think that gives you an impression of the difference between the unwinding and the ortho photo. So in those cases of curved shapes, we will rather apply the unwrapping than creating ortho photos. Already mentioned in relation to PointSense Plant and PointSense Building, that we also PointSense Heritage does have an enhanced visual interface with a scan navigation tool, so you can intuitively navigate from the scanner's perspective inside AutoCAD. It helps you to digitize without needing to crop your point cloud, and it also helps you that you don't accidentally snap background points. You have a fast scan-to-scan navigation via those scan labels. I will demonstrate it a little bit later. This scan navigation tool is only available in AutoCAD 2015 and 2016. If you have older AutoCADs and want to use PointSense Heritage, you can do so. By using the planner photo-like display, photorealistic display in a separate window, which gives you more intuitive navigation than inside the point cloud without scan navigation. Also here you don't accidentally snap hidden points, and an advantage of this option is that you don't even have to load the point cloud in AutoCAD. This photorealistic planner view is provided in a separate window. This separate window can be either VirtuSurf. The VirtuSurf license for sending into AutoCAD is included in the PointSense Heritage license, and also included is the usage of the Draw2CAD app inside Scene. So if you are a FARO user and are using Scene as pre-processing tool for scan registration, you can directly use the planner view or the quick view of FARO Scene in order to click points and send the coordinates into AutoCAD and PointSense Heritage. Let me go back one step back first. I like to show you the scan navigation tool. We have a small scan project here, and to use the scan navigation tool, you can create scan labels from your recap project by just clicking this button, and then you can switch to the scan navigation by selecting the scan labels, and then you can move around from the scanner's perspective and start digitizing whatever you want to digitize. And you can navigate to the next scan position by selecting the next scan label and moving around here. All right. Of course, you can always switch back switch off the scan navigation tool, and all your scans are visible again, and you can turn off those scan labels if they disturb your view. Do we still have some time? Yes, I think so. I'd like to give you a brief overview what's new in version 16.5 that just recently has been released. PointSense Heritage 16.5 is compatible with AutoCAD 2013 to 2016. It allows you to define horizontal slices at a defined level, as mentioned before. And I also already demonstrated the automatic polygon fitting tool to you. What I did not demonstrate yet is the one-click plane and the automatic rim tool for planar surfaces, but I will demonstrate them in a minute. And then I already demonstrated the new image management tool that simplifies working in AutoCAD with many orientated images. New in this version is also the Agisoft Photoscan import. That was a request by archaeologists and people of historical preservation to include this import in our software. And then there are a few more improvements in details which I will give you an idea as well. So fit planes with just one single click helps you to create average planes even faster than with the previous tools we had. So you can create planes for using them as construction aids as well as quickly setting the user coordinate system to them. It's nice to have this tool when I want to create an ortho image from a point cloud, for instance. And with this tool I also have an accuracy check because it also automatically creates a point cloud region, and the name of that point cloud region also contains the standard deviation in its name. So let me demonstrate it, how we can use this tool and together with the auto image tool. Let me switch to the facade here. I've cropped that to the facade, and what I like to do is fit a plane. So this new command is hidden here, and you can see there is this green thing is the search radius. I can set the search radius in the parameter dialog. I won't open this one. I just click to the point cloud, and in a few seconds, oh well, it's webinar transfer has slowed down this in here. So then we have the plane. If I turn off the point cloud, you can see the plane that has been created. And if I turn, and over here in the section manager, you can see that section has been created that shows us the points that have been used to create this average plane. And here we can see the standard deviation, so it's within millimeters, and it's due to the noise of the points. Let me switch on the complete facade once more, because why did I create this plane? I created it because I want to set the user coordinate system to that plane. And you can see that really the z-axis now of the user coordinate system now points towards me. There's also improvement in the UCS from plane command. Formerly it could happen that we would watch from the backside of the facade and now we improved it, and we take into account the current view of the viewport to get the correct direction of the z-axis of the user coordinate system. Now I want to create an ortho image. And new in version 16.5 is that I can not only create a an ortho image of the point cloud just by the RGB colors, but I can also create one ortho image that takes into account the visualization settings. So if I set from RGB to the intensity visualization style, and then run the ortho image command, the ortho image will be in those rainbow colors of the intensity view. I can do some resolution settings for me just to keep the calculation a bit faster for the webinar. I will select 5mm resolution, and I will select this qubit plane I just created as image plane, set the boundary for the ortho image, and it's going to be 5mm, and then I just hit create ortho image, and I will create a TIFF file, and I will create it at my desktop webinar. Save, and then it takes just a few seconds for the algorithm to calculate the ortho projection to the image plane I've selected, and then you will see the result inside the drawing. And it's going to be in the colors of the intensity colorized point cloud now. So this is new. Previously, even if you had switched to intensity view, the ortho image we created has always been in RGB colors, but now we can create those ortho images with a visualization style that we selected in AutoCAD. So here we've got the new ortho image, colorful. All right. We have a few more new functionality in PointSense Heritage. One of them is the option to automatically find the rim of a planar face with just one single click in the point cloud plane. We have the option to either create a plane or just the outline, the bounding polyline of the plane. So we can create it very fast, and we can also use it as surfaces for drawing on and for modeling. And to quickly create plan drawings. We have here, I will show you another example. I have here a drawing with a freestyle scan from a wooden staircase, and rather than digitizing the outline of this plane, top plane here manually, I will just run the new command for creating the automatic rim. Again, here I can turn on parameters. I can set the search radius for that tool. I can also set a smoothing tolerance. That's for the outline, and I want to create just a 3D polyline. I hit OK here, and then once more I need to turn on the object snap. Node of point cloud. Just refreshing here. So that's strange.
I think you just need to choose the
okay, I just need to check the automatic plane option in here. Actually, it should show the search radius in here.
Yeah, turn on the snap.
Yeah, I did it. already. I turned it off. Oh, sorry, my fault. Okay. I did turn it on. Now you can see the green search radius around my point snap, and when I click, the algorithm will take a few seconds to automatically find the boundary in here. Still not complete yet. Adjusting it a few times, and there we get the outline. If I turn off the point cloud, you can see the outline that has been found. So I think that gives you an idea how you can quickly generate outlines of planar faces with PointSense Heritage. There are a few more improvements in details. We added an offset option to the Insert Point Cloud tool. That's for users who registered their scans in large coordinates, like in geodetic coordinate systems. You can, during insertion of the point cloud, you can move those closer to the origin in order to prevent problems with processing at large coordinates that AutoCAD sometimes has. And the recap photo import has been revised a little bit. In the auto photo tool, we have added an option to use the point cloud information in addition to the photographs. Previously, it was the way that the point cloud information has always been used to fill the gaps between the photographs, if there were gaps between the photographs. This was not what all our users wanted, so they asked us to make it optional. So now you can turn this option off and create the orthophoto just from the photographs without filling gaps by point cloud colors. Another minor improvement was done to scan navigation, so it's now automatically isolating the scans when switching to the scan navigation, so we really cannot snap any false points. I already mentioned that UCS from plane has been enhanced using the current view information. Flatness analysis also now uses the current view information for the alignment of the text of the deviation grid. And we added a new command for creation of rotated arc plans. That was also a user request. This tool originally comes from our total station software TachiCAD. So we added it to PointSense Heritage on user request, and it's meant to draw 3D arcs into the 2D plan. This is a requirement usually in cultural heritage drawings. I don't know if it's condition for worldwide, but in Germany and in Austria and Switzerland we do have this requirement for ground plans of historical buildings. So that's why we included this tool in PointSense Heritage. And I already mentioned those enhancements in the author image tool, taking into account the current view. So we don't have an author image from the backside of our facade, but from the front. And as mentioned, we are using now the colors of the visualization settings of AutoCAD. That's all that I wanted to show you and tell you about PointSense Heritage. I'm now here to answer your questions live, but if you have questions later on, you can send them to info@faro-3d-software.com. And please note that there are also some tutorial videos on our YouTube channel. Thanks for your attention so far.
Thanks, Jana. Yeah, let me pull the screen back here and finish up. So Okay. So if you made it through all 3 sessions, you are a champion. Let me go through some questions here. Now, Jana, you were showing the working with photographs from the Agisoft and from the recap photo. Are there people using this with aerial drone photography as well?
Yes, there are people using it with aerial photography as well. Not sure if those people are from the field of heritage, but yes, there are people using it, especially the Agisoft software, because there are much more possibilities to adjust to control points than you have in recap photo. And we just recently adjusted our camera navigation tool to more smoothly navigate with pan and zoom for those airborne photographs.
Okay. Yeah, I was just thinking because especially the shot on the that's actually for those of you that are seeing the screen, that's the Qubit office in Germany, or the previous Qubit office, now FARO 3D software.
Yeah.
That's a
The
very
roof
cool.
is missing.
Yeah, I was thinking it would be a very nice application for
That's
that.
true.
And also, just combining our planar analysis tool, even for people needing to do maybe ground extraction, you can
That's
use the
right.
photographs.
That's right. Even if you make shots of taller buildings, you might want to use a drone and take photographs, which can be taken much faster than a scan. So photographs are really an alternative to scanning when it comes to capture tall buildings and need to take a drone or a lifter to get the complete facade without any occlusions, because if you just scan or photograph from the ground, then you won't get everything.
Right. Can the automatic rim tool be used to outline stones or elevation drawings automatically?
To outline stones depends on how accurate you want to get the outline. But yes, if you have sharp outline of stones, yes. To get elevations or facade lines using this tool, it is a tricky thing. I think it's very difficult.
Yeah.
Also depending on the data and if you have occlusions in your point cloud. So I actually would not recommend using this tool for creating facade plans, for instance.
Okay. More of like rough estimations.
That's right.
Yeah.
Or like in that staircase example, there it worked quite nicely, but for the facade we tested it up several ways, and it's not really meant for that.
All right. It's another case of when you over automate, it causes problems.
Right.
Okay, I think that's about it, and we're about out of time. So,
Okay.
as Jana mentioned, if there are any more questions, I'll pull up the email again here. Just one more mention. Additional upcoming webinars, if you didn't already hear me mention, go to our website. You can go to FARO3Dsoftware.com. You can click the banner at the top of the page, and that will give you more information on the releases. We can get more info on what's new for each product, and also will lead you to where you can register for each of these upcoming webinars. Again, if you have interesting stories for using the tools, using Autodesk Point Clouds, we'd love to hear them. We have 2 classes that we're going to be teaching at Autodesk University this year, so we encourage you to sign up for those. But why not be the star of the presentation as well? Let us know your stories. Contact your local FARO 3D software person and let us know. And then, okay, finally, so if you want to email us, again, at info@faro-3d-software.com. The website's listed, and of course the YouTube channel again. I've listed both office addresses here based on where you're located for FARO 3D software, both Dresden and Houston. Again, for those of you that made it through all the sessions, congratulations. You win a high five from me if I ever see you. But otherwise, we hope you enjoyed it, and thank you for attending. And we will be sending out the recording shortly. I wish you a nice rest of the week, and that's all. Goodbye.